Today we're going to be talking about an ellipse. An ellipse is part of what we call conic sections, and it makes a circular kind of shape, like a squished circle. Okay, so the technical definition is the set of all points P in a plane, the sum of whose distances from two fixed points called F1 and F2 is constant. These two fixed points are called the foci. Foci is plural for focus. So if there's one of them, you say focus. If you're talking about multiple, you say foci. Okay? The midpoint of the segment connection of the foci is the center of the ellipse. So here we have, this is our focus, this is our focus, and together we call them a foci, and then we have the middle of those is the center. Okay, so this is your elliptical shape. It does finish the shape up here. It just got cut off when it was copied. So that up there. Okay, so the technical definition says that the sum of the distance from the point on the ellipse to the two different foci, so this distance, and this distance, and any other distance of a point to the two foci is the same for all of the points on the ellipse. Okay, so you can create an ellipse using two pieces of strings, and you tack down the piece of string, and those are your foci, and then you can create your ellipse like that. So if you want to watch a YouTube video, you can use that QR code and you see that. Okay, so we have a couple of definitions. The vertex, the line connecting the foci intersects the ellipse at 2 points called the vertices. So we have this right here is a vertex, and this right here is a vertex. Remember, vertices is plural of vertex. Okay. On the other picture that we have, this would be your vertex, and this would be your vertex. Okay. I'll refer to these other 2 points as vertices as well. Your book does not refer to them as vertices, but they are still important points. Okay. Then we also have the major axis. Okay. The major axis is the longer of the two axes. So it goes through your center and it goes horizontally or vertically. Okay? And it depends on which way your ellipse is oriented. So it could be either oriented so that you have a horizontal major axis or you have a vertical major axis. Okay? And the definition is that it connects the two vertices. So here and here. Okay? The minor axis is the other direction. It's the shorter of the two of them. So here's your minor axis, here's your minor axis. Okay, it's perpendicular to the major axis and goes through the center as well. And then these 2 points help create the vertex when we're graphing it. Okay, so we already talked how you can have two orientations, one where your major axis is horizontal and one where your major axis is vertical. Okay, so that means that we have two different equations, one for when it's vertical and one for when it's horizontal. So if you have they look exactly the same, the two that you have, except for the only difference is that the A's and the B's are switched. So that is where this part right here, where A squared is greater than B squared, comes into play. So basically, whichever number is bigger on the bottom is going to be where your major axis is. Okay. Now, it's similar to graphing a circle, which we touched on when we were talking about polar, where the center is the opposite of inside both sets of parentheses. So notice that from negative h to h and negative k to k in both sets of equations that you have. Okay. This equation goes with this one, this equation goes with this one. Okay. Now, the A distance is the distance from the center to the vertex, and your B distance is from the center to the non-vertex one that we're going to call another vertex. Okay? So this is your A distance, this is your B distance, and then we have what we call a C distance, and this C distance is the distance from the center to the foci. Notice your foci are always on your major axis. So this is your foci, this is your foci, okay, just the one that's right there. That's your focus, that's your focus. Okay. And the same is true over here. The distance from The center to the vertex along the major axis is going to be your A value, and then the center to the non-vertex part that is sort of a vertex is going to be your B distance, and then your C distance is, that looks like a C now, from the focus to the center. Okay, so what we use is this equation right here to be able to find what our C is so we can locate the focus. Okay. Oh, and I have all the A, B's, and C's written down here, which I had forgotten about. Okay. Your foci are either going to be located at H and then K plus or minus C, which is when I have this part right here when your major axis is vertical, or it's going to be H plus or minus C, K, and your major axis is going to be horizontal. Okay. So it sounds a little bit complex, but when you're graphing it, it's actually not too bad. So let's do an example. Okay. So this part just tells you how to do what I'm going to show you right now, so we're not going to read through it explicitly. Okay, so first of all, we decide which one is going to be the major axis. So we decide which number is bigger on the bottom. So since 36 is bigger than 4, your major axis is up and down because it's underneath the y. So your major axis is up and down, which means that my A value, or A squared, is 36, so then our A value is 6. Okay, normally we put plus or minus. We're going to forego putting plus or minus and just keep it as A at this point. So B squared is 4, so our B is 2. Our center, notice I have nothing inside parentheses with the x or the y, so that means our center is at 0, 0. So I start at 0, 0. The major axis is up and down. Basically what you want to remember is that if it's underneath the x, that's where you go left and right. If it's underneath the y, that's where you go up and down. So since the 4 is underneath the x, I'm going to take the square root of that, which is the b part, and you get 2. So I'm going to go left and right by 2. So here's 2 and here's 2. And then the a value is underneath the y, which means I'm going to go up and down by 6. So I go up 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6. So now I'm going to create an elliptical kind of shape and try and make it look nice and curvy as possible. Kind of like that. Now, in order to find the foci, I need to use my equation a squared minus b squared equals c squared. Our a value is always the bigger one, so I'm going to take 36 minus the b squared, which is 4, and that gives you c squared. So 36 minus 4 gives you 32. So c is the square root of 32. Well, 32 breaks down to 8 and 4. This is 4 and 2. I have a pair of 4s and a lone 2. So our c value is 4 root 2. So since our major axis is up and down, in order to find the exact location of the foci, I'm going to take our center. I'm going to take the center and I'm going to move up by c and down by c. So I'm going to start at 0. I'm not moving left or right because the foci is up and down. And then I'm going to take 0 plus or minus 4 root 2, which just turns it into 0 plus or minus 4 root 2. So that's where our foci are located at. If you want to graph the foci, if you need to graph that, you need to figure out what 4 root 2 is, and you can use your calculator to get a decimal approximation. So 4 root 2 is 5.65. So I would have 1, 2, 3, 4, 5.65. 1, 2, oh, I didn't count quite right. 1, 2, 3, 4, 5.65. Okay. Let's have you try and graph this one by yourself, and let's see if you do it right. So pause the video and try it. Okay, this one is slightly different because one of them is not a perfect square, so let's see how you did. Your center is at 0, 0, because I have nothing inside the parentheses. Your a value, a squared rather, is 49, so your a value is 7. Your b squared value is 20, which means that your b value is root 20, which simplifies to 2 root 5. Okay? So it's still fine that this is not a perfect square. That doesn't mean that you can't do it. It just means that it's going to be a decimal approximation as you're graphing. Okay? So my center's at 0, 0. Since the 49 is underneath the x, I'm going to move left and right by 7. So this time it's oriented horizontally. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to move up and down by 2 root 5. 2 root 5 on your calculator is 4.47. So up by 1, 2, 3, 4.47. 1, 2, 3, 4.47. So then I create this sort of kind of elliptical shape like that. Okay. So if I wanted to find the foci, I'm going to take your a squared minus b squared equals c squared. So I'm going to take 49 minus the 20 is the c squared. So you have 29 equals c squared. So c is root 29. So your foci are going to be located at, this time, since we're moving left and right for the major axis, I'm going to take the center of 0, 0, and I'm going to add the c value to your x value of your center. So I'm going to do 0 plus or minus root 29, comma 0, which just turns into root 29, 0. Plus or minus root 29. Okay, so the bottom left one, now we have a different center. Okay, so our center is the opposite of inside the parentheses. Switch to blue. So I'm going to take the opposite of this and the opposite of this, so your center is located at 2, 4. Your a squared value is the bigger one, so it's 4, or sorry, I took the square root, 16, so a is 4. And then your b squared is 9, so your b is 3. So now, all I do is I'm just changing where my center is located. So I go right 2 and up 1, 2, 3, 4. So then my a value was underneath my y, so that means that my major axis is going to be straight up and down. So I go up 1, 2, 3, 4, 1, 2, 3, 4, left and right by 3, 1, 2, 3, 1, 2, 3. Oops, I kind of missed. Okay, so to find your foci, you take a squared minus b squared equals c squared. So I have my a value is 16, my b value is, b squared is 9. So 16 minus 9 gives you 7. So that gives you 7 is your c squared, so c is root 7. Okay. So that means that your foci are going to be located, remember your major axis is with the y, so it's up and down. So I'm going to take the x value of my vertex, which in this case is 2, or not my vertex, sorry, the x value of the center. So I'm going to take 2, I'm going to keep that the same, and then my y value, I'm going to add the c value so that I can get my foci that are going up and down. So I take 4 plus or minus root 7, and I just leave it like that. Okay. Then let's have you try this next one by yourself. So pause the video, try it, and let's come back and see how you did. Okay, let's see what happened. So your center is at -7, +5. And your a squared is 25, so your a is 5. Your b squared is 4, so your b is 2. So I go left by 7, 10, 9, 8, 7, and up by 5, 1, 2, 3, 1, 2, 3, 4, 5. Okay, so there's my center. It's going to be, the major axis is going to be up and down. So I'm going to go up by 5, 1, 2, 3, 4, 5, and down by 5, and then I'm going to go left and right by 2. Okay, and then your c squared equals a squared minus b squared, so you should have got c squared is 25 minus 4, so c squared is 21, so c is root 21, which you can't break down or simplify. So your focus, or your foci rather, are going to be at, since it's up and down, I'm going to take the x value and keep it as it is from the center, so -7, And then I'm going to take the y value, which is 5, and add the c value to it. So 5 plus or minus root 21. That's your foci. Okay. When your equation looks like this, it's not in standard form. Notice it's not equal to 1. Notice that all of our previous ones have been equal to 1, and that on your standard form that it's equal to 1. So in order to get this graphed, I have to get this to equal 1. Well, the way that I get this to equal 1 is to divide by 144. So if I divide, your equation is now going to be, if I simplify 16 divided by 144, I get 1/9. So this is going to be x minus 3 squared over 9 plus, and then 9 over 144 simplifies to 1/16. So I get y plus 4 quantities squared over 16 equals 1. So now I can graph just like I did before. So your center is the opposite of inside the parentheses, so 3. Opposite of inside the parentheses, so -4. Your a squared is 16, so again it's oriented as a major axis is vertical. So your a is 4. Your b squared is 9, so your b is 3. So 1, 2, 3, 1, 2, 3, 4. And then I go left and right by 3, 1, 2, 3, 2, 3, and then up and down by 4, 10, 9, 8. Create your ellipse. The foci are located since a major axis is up and down, I'm going to add to the y value of the center, so I'm going to take 3 and -4 plus or minus the c value, which I didn't find yet, that's why I can't find it on my paper. C squared is a squared minus b squared, so I have 16 minus 9, so c squared is 7, so c is root 7, so then I do plus or minus root 7. Okay, try the next one by yourself, see what you come up with. Pause the video. Okay, so first you have to divide by 36. That is the same color that I was using. When I divide by 36, I get x squared over 4 plus y minus 2 squared over 9 equals 1. So this means that your center, notice this one does not have anything inside the parentheses, so it defaults to 0. So this is 0, 2 for your center. The a squared is 9. The b squared is 4. So it's a major axis up and down. So your a is 3 and your b is 2. So your center is at 0, 2. I'm going to go, since the 4 is underneath the x, I'm going to go left and right by 2. And then I'm going to go up and down by 3 on the y. And there's your ellipse. The foci, I'm going to find by doing let's do the equation first. C squared equals a squared minus b squared. So your c squared is a squared, which is 9, minus 4, which gives you 5. So your c is root 5. So your foci is located at, you're going to add to the y value of the center, so the x stays the same. So 2 plus or minus root 5. I can't simplify that, so I'm done. Now, if I wanted to try and find out what the standard form of the equation is, and I have the foci and the vertices. Remember, the vertices in this case is just talking about along the major axis. So the major axis relates to your a value. So that means that my a value is 6. Okay. Notice that my major axis is left and right because my vertices are going left and right, or so are my foci. Notice that halfway in between your positive and -6 is where your center is going to be. So your center is at 0 for your x value, because that's halfway in between your positive 6 and your negative 6, or positive 6 and your -6, and as well as your positive 2 and -2. And then since this is 0, the y value of your center is also 0. Okay? So my A value is 6. My C value, because you remember you use your C value to get to the foci, so your C value is 2. So if I want to create my equation, I'm going to do x squared plus y squared, both of them over something, equals 1. Remember, your a squared has to go with your x's. So a squared would be 36. So if a squared is 36 plus your b or minus your b squared has to equal your c squared, which is 2 squared. Okay? Oh, I should have put 4. So I have 36 minus b squared equals 4. So if I add the b squared to the other side and subtract the 4, I get 32 equals b squared. So b squared is 32, so 32 goes underneath the y squared. Notice I use the b squared, not the b that went underneath here. Okay? And there is your standard form of the equation. Okay? The next one's a little bit different because it talks to you about the major and the minor axis. If the major axis is vertical, that means that you're going up and down, okay, and it has a length of 12. Notice your major axis is double your A value, or your minor axis is double your B value. So if this is 12, that means that my A value is 6, which means that A squared is 36. If the minor axis has a length of 4 and it's horizontal, then that means that your B value is 2, because I cut this in half, which means that my B squared is 4. Okay? One potential equation, it doesn't give us anything about the center, right? So this could be moved all around the graph. So we're just going to put the center where we want it, which is easiest at x, or at 0, 0. So I have x squared over, remember the x goes with the horizontal, so over b squared, which is 4, plus your y squared over the a squared, which is 36, equals 1. This is a plus. Okay? And that gives you your standard equation. Okay, now, you have to remember how to complete the square root. So it's been a little bit of time since you've completed the square. We have what we call the general form of the hyperbola, not hyperbola, we're on ellipsis, of the ellipse, okay, where it's written like this. So it's not in your nice format where you can get the center easily. So what we're going to do is complete the square. So in order to complete the square, what you're going to do is group the x's, group the y's, and put the number on the other side. So this turns into 4x squared plus 8x. I grouped the x's, and, oh no, we're not going to do that yet, plus 25y squared minus 150y, so group the x's, group the y's, and put the number on the other side. So I'm going to put negative 129 on the other side. Okay, so the next thing you're going to do is factor out any number in front of your x squared or your y squared. So I'm going to take out the 4 out of both of these terms right here. So 4x squared, or 4 times x squared plus, and then 8 divided by 4 gives you 2x, plus your blank. And then the blank sets up what you're going to do for completing the square. So that's why I have this blank here, because I'm going to put a number here so I can factor this so it ends up looking like our equation up here with this part. Okay? So now I'm going to factor out the 25 out of these two sets, or these two terms. So I take out a 25. There is a common y in both of these and a common x in both of these, but since I want to factor this part, I'm specifically choosing not to factor out the x and the common y. That's why I'm leaving them in there. So if I factor out the 25, I have y squared minus, and then 150, 25 goes into that 6 times, so I have 6y plus blank equals negative 129, and I'm going to put plus blank plus blank. Because remember, in order to keep your equations equal, if I add something on this side, I have to add the same thing on that side. If I add something on this side, I have to add the same thing on that side. So I can change this to green so it kind of color coordinates. Okay. So in order to find this term right here, you're going to take b divided by 2 and square it. Your b term is always your linear term. So I'm going to take 2 and divide it by 2 and square it. So 2 divided by 2 is 1. 1 squared is 1. Now, on the other side, I added 1, but I really added 4 times by 1 because I'm multiplying by 4. So I'm really going to add 4 here. And then for this, completing the square, I'm going to take negative 6 divided by 2. It's your b divided by 2. And I'm going to square it. So I get negative 3 squared, which is a positive 9. Well, I really multiplied 25 times by 9, which gives you 225. Okay? So, remember when you're adding the number on the other side that you have to multiply it what you multiplied out in front. Okay? So now I'm going to factor this part right here. So I keep the 4 there, and then this, you've contrived it to factor nicely. It's always going to be whatever your term is before you square it. So the 2 divided by 2 was a 1, so it's going to be 1. Or you can think, what multiplies to 1 and add to 2? Well, it's 1 and 1. So this turns into x plus 1 quantity squared. On this one, plus keep the 25, I factor this, so what multiplies to 9 and adds to negative 6? Negative 3 and negative 3, which notice that's our term of b divided by 2 right before we square it. So y minus 3 quantity squared equals, and then negative 129 plus 4 plus 225 gives you 100. Okay. Now we're really close. Now we're up to the part where it looked like these two up here. So I'm going to divide by 100 on each side and each term. So this now turns into 4 divided by 100 is 25, so x plus 1 squared over 25. No, 4 divided by 100 is 1/25, so the 25 is on the bottom. And then 25 divided by 100 simplifies to 1/4, so I have plus y minus 3 squared over 4 equals 1. Okay? So that's how you complete the square. Okay? Let's take a look at this one. Let's have you try that by yourself and see how you end up. Okay, let's see how you did on the problem. So here's what you have. This is what you get at the end. Take a look for a second, pause the video, see if you got it right. Okay, now our next part, a semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Your truck is 12 feet wide and has a height of 9. Will your truck clear the opening of the archway? So, you have this archway, and you have your truck. That's the back of the truck. And your truck is, what did it say? 12 feet wide? Okay. And has a height of 9. And so we're going to put our axes, we're going to impose an axis on our picture with our elliptical archway. Okay, so we're going to put our center at 0, 0. And it has a height of 10 feet, so from here to here is 10 feet. And it has a width of 40 feet, so from here to here is 40. Okay? So the question is the truck going to clear it? Okay? So here's what we do. First, we're going to create our equation. So our equation, if we're just looking at the elliptical archway, it's semi-elliptical because it's just half of an ellipse. It's centered at 0, 0, so I have x squared plus y squared equals 1, and it's over something. Well, this is our major axis. Notice it's longer. This is 10 feet. It's half of your minor axis, so if I do 10 plus 10, that gives you 20. So the 20 is smaller than the 40, so this is your major axis. Also, it's left and right, so I'm going to put it underneath the x. But remember that your a value is just half the distance, so I'm going to put 20 squared underneath the x. And then the y is already the half distance, so I'm going to put 10 squared underneath the y. So this simplifies to x squared over 400 plus y squared over 100 equals 1. Okay, so Now what I have to do, the truck, since the truck, we put the truck the center way through because it says that it's a one-way road, so you're not counting two different lanes on the highway, or road, whatever it is. Okay, so your truck, you're going to split it in half, so this is 6 and this is 6. So I want to know what this is right here. Okay, how high it is at your x value of 6. So if I know that my x value is 6, I want to find out how high it is. I can plug in my 6 value right here to my x and find out if what the height of the elliptical arch is, and then see if my truck is going excuse me, see if my truck is going to clear it. So if I plug 6 in, I get 6 squared over 400 plus y squared over 100 equals 1. So this is 36 over 400 plus y squared over 100 equals 1. So if I do 36 divided by 400, that gives you 0.09 plus y squared over 100 equals 1. So I'm going to do 1 minus 0.09 because I'm going to subtract the 0.09 to the other side. So now I get y squared over 100 is equal to 0.91. So to get rid of the 100, I multiply both sides by 100. So when you multiply both sides by 100, I get y squared is 91. So if I take the square root of 91, whoops, that's not the button I wanted. Okay, not 1, 91. I get y is 9.539. So right here at 6 feet over where your truck ends, the height is 9.539 feet. So since your truck is only 9 feet, I kind of put the picture off. So you're looking at 6 feet over. You have a height of 9.539, which is what we figured out. So now since your truck is 9, you know that it's going to clear it, so you get to drive through. Not that you would really do that math before you drove through. Plus, there's already the clearance thing. But probably somebody figured that out to figure out what the clearance was. So, there's your ellipses.